Okay, we stopped right here last time, and one of the things I mentioned about free rotating carbons is um, around a single bond, they freely rotate. And they'll spend more time in the stable position than in the unstable position. So what you're going to do, you're going to minimize steric hindrance. Now, the exception to this is a ring. Ring alkanes are rigid. I.e., that means they're not freely to rotate. Six-membered rings are the most stable. Three-membered rings are the least stable. Yes. Okay. So when you have rigidity, you can have something called isomerism. Oops. And an isomer, remember from the last lecture, it has the same formula. But different structures. For example, there are two isomers here. There's this one and there is this one, C2H6O. Now, in a situation with a ring, you can have methyl groups in two different configurations. One on the left, one on the right. Now, those are not the same cyclopentane. And you've heard of trans fats being bad. Same thing with trans fats. There's a cis fat, which is the natural fat, and trans fat, which is an artificial fat. Our bodies have trouble digesting trans fats with the enzyme lipase. Lipase is designed to digest cis fatty acids. So the effectiveness of lipase on a trans fat goes way down. That's why trans fats are not good for you. And our government's put a pretty good effort into minimizing trans fats. Okay, so so whenever you have rigidity, red flags should go up. Are there isomers available from that rigidity? For example, here, this cyclopentane. Those two methyl groups are on this next to one another. These are opposing. Now think of sister and cis. Sisters are close. methyl groups are on the same side, close. Trans, think of transatlantic. And those would be farther apart. Now, these can be two OH groups. It could be two chlorines, it could be two bromides. It doesn't really matter what the group is. If they're together, you need to I'll call it out, it's either cis or trans. Okay, so does that make sense? Okay, now in 305, you guys went over intermolecular forces, right?
Yes.
Okay. I'm going to talk a lot about intermolecular forces in this class. So I'm glad this is going to be a review. So I call them IMFs, intermolecular forces. Those are the forces between a molecule. There's inter and intra, not the same thing. Intra and they don't have to be the same molecule. They can be, for example, or it can be only that. So it doesn't have to be the same molecule. It could be different molecules. Okay. And when I write IMF, I'm referring to the intermolecular forces. Okay, now, I'm sorry, what? Anita, did you have a question?
Sorry, Professor, my mic was on. I'm sorry about that.
No, okay. Okay, so now there's a very general statement called like attracts like. So if you have a nonpolar molecule, it's going to be attracted to another nonpolar molecule. If you have polar molecule, it's going to be attracted to a polar one. If you have polar and nonpolar together, they are going to separate. So so alkanes are very nonpolar. So when you're trying to dissolve some grease, for example, water doesn't touch grease because water is very polar. However, if you took something like gasoline, gasoline is very nonpolar. It's mostly octane. It will easily dissolve the grease. Okay. So hydrophobic means water hating. Things that are hydrophobic. Wait a minute. Hydrophilic loves water, so it's very polar. Hydrophobic is nonpolar, hates water. Okay. Usually alkanes are less dense than water, meaning their density is less than water, i.e. they float. That's why grease floats. Now, a molecule can have, if it's big enough, can have both polar parts and nonpolar parts. Fatty acids are a good example. Now, okay, as we go higher on this graph, you'll see the polarity increase. So at the bottom, we have something called London dispersion forces, or LDF. They are the weakest. The next one up is dipole-dipole. Next one up is hydrogen bonding. And then at the very top, we have ionic. Sometimes ionic is on the list, sometimes it's not, depending on what textbook you're using. Okay. Now, hydrogen bonding is hydrogen that bonds to nitrogen, oxygen, fluorine. So whenever you have an OH around, it's a very polar part of that molecule. And we're going to be talking about alcohols as far as unit 1 goes. And I'm going to really stress that. When you have nitrogen, it's also polar, and that's where the amines come from. And then we don't have fluorine in our body. I don't usually cover fluorine, but if H is bonded to fluorine, it's also hydrogen bonded. Now, you can have hydrogen or dipole-dipole, but if it's not bonded to nitrogen, oxygen, or fluorine, it's not hydrogen bonding, so it isn't as strong. And this has to do with electronegativity. So fluorine is the most electronegative in the periodic table. Californium, down towards the bottom left of the periodic table, is the least electronegative. Okay, so this is where alkanes are. right down here. All they have is London dispersion forces. All molecules have London dispersion forces. Now, frequently on a test, I will ask you, list two things in order. I'll give you like 5 molecules. List in order of increasing boiling point, and then list the intermolecular forces per molecule. Every test. So if we look at okay, that's 3-carbon alkane propane. And we look at a 3-carbon alcohol. That is isopropanol or rubbing alcohol. Okay, so list the IMFs. Okay, first of all, right away you're going to write down LDF for both of them, because all molecules have London dispersion forces. However, we've got oxygen, carbon, and we have oxygen, hydrogen. So this is a let's do this one. So the carbon oxygen bond there is a dipole-dipole. The oxygen hydrogen has hydrogen bonding. So we have H bonding, dipole-dipole. Sometimes the dipole-dipole is called permanent dipole. Mostly called dipole-dipole though. Okay, so those are all the IMFs for those two molecules. And the more polarizing intermolecular forces you have, the stronger the attraction between those molecules are. So if we look at electronegativity, is directly proportional to polarity. So the higher the electronegativity, higher the polarity, the higher the attraction. In molecules, think of it as glue. So the stickier the molecules are, the higher the boiling point. And melting point. So knowing these three, by the way, this is directly proportional. So Since the propane on the left does not have any of those stronger intermolecular forces, it's going to have the lowest boiling point. Or melting point. Now, if we have two molecules, like let's talk about propane, and then we have pentane. Propane has a lower boiling point than pentane. But because there are more carbons and hydrogen in pentane, it has more LDFs. Even though LDFs are weak, if you have more of them, it'll still be a stickier molecule than propane. Hence, the boiling point of propane is lower than the boiling point for pentane. Now, when I say boiling point and melting point, those are indicators of how attractive the molecules are to one another. So whenever you see boiling point, think of it as a molecular attraction or melting point. So the more IMFs you have in similar molecules, 3-carbon alkane, 5-carbon alkane, the LDFs are going to win out. That's all that's there. So if you have more LDFs, that one's going to boil higher and melt higher or be more attractive. Now, there's one other thing I want to talk about regarding IMFs. Surface tension. Same thing. The more polar the molecule, higher the surface tension. Surface tension, again, has to do with attractiveness between molecules. The more glue between the molecules, the stickier they are, the higher the surface tension. Now, water has got one, it's a small molecule, and the only bonds, intermolecular forces, are LDFs and hydrogen bonding. So it has very strong intermolecular forces, very strong. So its surface tension is going to be quite strong as well. That's why mosquitoes can land on the surface of a water lay its eggs, then take off without being drowned. One of the techniques for minimizing mosquitoes breeding is to lower the surface tension of the water that it's sitting in. When I lived in Florida, I lived in southern Florida when I was in junior high back in the early 60s. And the base would come around and put drops of gasoline on all the puddles. It used to rain a lot there too. I mean, a lot. And so the mosquitoes couldn't breed that way. But, you know, on the other side of the fence, they had puddles and they bred fine on the other side of the fence, which besides that, they used to spray DDT there as well, which is really bad stuff. Okay, so anyway, IMFs are going to be a very common topic. You notice this graph here. This boiling point, or IMFs. Notice that these molecules are just made up of carbon and hydrogen atoms, all the way up to carbon-16. So they all have only LDFs, but the bigger the molecule, more LDFs, hence higher boiling point, surface tension, same graph. Okay, now, carbon is a very strange atom. It does something called bond hybridization. And I don't cover that in this class. In my opinion, there's no need to know this to have a understanding of organic chemistry, at least at our level in this class. So I'm not covering bond hybridization. What happens is the normal bond hybridizes to a new bond. This is why carbon has got 4 single ends and not 2. And the name of the orbital is sp3. And that's also what makes the molecule have a tetrahedral shape. Okay. So reactions now. There are only 2 reactions for alkanes. Now remember, every test, every subunit is going to build on the previous one. So one of the things I've made for you guys something called Unit 1 reactions. And I'm going to give you a copy of this for your tests. Okay, so these are all the reactions for Unit 1. Unit 2, I've got this same one built up even more. Okay, so right now we are right here. And it's got really 3 reactions. If you look at this one here, so we have haloalkane or halogenation, and then we have a spark or combustion, and we can also take off hydrogens, and that's biochemically only. Okay, so let's, and I'd recommend download this and printing it. You'll be using that a lot. Okay, and then we have one other thing here that okay, which is the loss of hydrogen atoms or oxidation. Now, I'm not going to talk a lot about this third one until we get into the next subunit on alkenes. Okay. At the beginning of this slide presentation, they talked about organic molecules having very slow um, reaction rates. Well, combustion goes really fast. Plastic explosive, also organic, goes quite fast. TNT goes quite fast. All those are organic reactions. So it varies a lot. It can be super slow or it can be really fast. Or a combination of the two. For example, when we make soap, the beginning phases of making soap, it goes very fast. But the last part takes months. So it slows down tremendously. That's why whenever you make homemade soap, you should always let it cure for at least 2 months. So at the end of the semester, you get to take home your soap you made. And by that time, the reaction will have totally finished. Okay, so let's look at combustion. As you already know, methane coming out of the wall, propane for your gas grill, butane lighters, gasoline, diesel. These are all hydrocarbons, alkanes, and they burn quite nicely. So combustion is an alkane plus some kind of oxidizer. Usually it's oxygen. Not always, though. Most of the time it's oxygen. And then we've got carbon dioxide and water. So for example, if I had propane, I'm going to get carbon dioxide and water. If I have gasoline, same thing. Different amounts depending on the complexity of the alkane, but you're still going to, when it burns completely, you're going to end up with carbon dioxide and water. Completely, okay? Key word there. Sometimes the reaction of combustion is not complete because we lack available oxygen. So what you end up doing is creating carbon monoxide and water, or just plain old carbon and water. Now, the state of California wants to outlaw gas cooking stoves. This is why. Right there. Because if your gas stove isn't properly tuned to make sure you get the proper amount of oxygen in relation to the fuel, you will produce carbon monoxide. Now, I'm really into cooking, and I like electric stoves and I like gas stoves. Each one has their own pros and cons. Gas stoves cost more because you have to install a gas pipe underneath into your stove, or electric one, you just plug it into an outlet. And some people really like gas over electric. Now, whenever you're on a campfire and you cook over a campfire, you'll notice the bottom of your pan is all black. That's because that campfire doesn't have enough oxygen to completely burn the methane. So you end up with plain old charcoal. Now, if we look at the reactions, notice that a lot of things go to carbon dioxide and water. So it doesn't matter if it's an alkane, alkene, or an alcohol, it'll still go to carbon dioxide and water, assuming you have adequate amount of oxygen. Okay, so that's your first reaction. We're not going to do stoichiometry in here. Okay, the next reaction is something called halogenation. Most of the time, we're going to be dealing with chlorine. Sometimes we introduce fluoride, for example, when they fluorinate water, or treat your teeth with fluorination to increase the sturdiness of your enamel. But it's not a naturally occurring compound, and there's some controversy about how safe that is as well. Chlorine is pretty common. It's not natural though, but our bodies can tolerate it well. And bromine and iodine are two that are used less frequently than chlorine, and our bodies do okay with it. So we're going to generalize halogenation with the letter X. So if we have an alkane, and alkanes have lots of CH bonds. Plus, this could be like like Cl2, Br2, F2. We are going to produce a alkane with multiple halogens on it. So say we were looking at propane. Now, the problem with halogenation this way, it's not very efficient. So the problem is you end up with a mixture. It just depends on how long or extreme these conditions are. Now, reactions have three parts. There's the reactant, conditions, and products. So in this case with propane and fluorine gas, so the reactants are propane and chlorine gas. The conditions are UV and heat. And the product is just the different combinations of where that chlorine will lie along the carbon backbone. So we could have that. So this would be the main one to write down, or one with one single chlorine on it. Either way is fine. Now we're going to be using R's a lot. R is a general alkane. So we're saying alkane with an H, chlorine gas, and this slide talks about the mixture products you get, with one chlorine, two chlorines, three chlorines, till it's totally used up. Okay, so let me show you what a typical question would be. I would say, how do you make that? Okay, whenever you do a reaction on a test, first thing you're gonna do is label everything. Products, reactants, conditions. Okay, the conditions for doing this is gonna be heat and UV. UV stands for ultraviolet energy. And we're gonna start with the backbone. It's a 5-carbon backbone. We're going to halogenate it with chlorine gas. So that's how I'd make this 3-chloro pentane, starting with pentane plus chlorine gas. And the conditions are that guy. So that's one type of reaction problem where I say, how do you make this? I give you the product, you come up with a single or 2 or 3-step process to make that. Then you've got to label everything. Name the reactants, pentane, chlorine gas. Name the conditions, heat, UV. Name the product. Now, every test, you're going to have naming, structures, intermolecular forces, and reactions. Every single test. So, are there any questions about reactions? You're going to be practicing this a lot in here. Okay, so let's do another example here. Let's say you've got cyclohexane. And we have a spark. What are the products? Well, that's combustion. Products of combustion are always with adequate oxygen, carbon dioxide, and water. We need to add some oxygen gas here. So again, what are the conditions? Conditions are spark. We have oxygen gas and cyclohexane. And the products are so two kinds of reactions. One, I give you the starting material, in this case, cyclohexane and oxygen gas. How do you make carbon dioxide? Well, you need a spark. You just supply the missing parts. Okay, so we're gonna assume that halogenation occurs once, but it usually happens as a big hodgepodge. There's a pesticide my first wife used to work on. She was a environmental toxicologist over at university, and there is a really horrible pesticide called toxaphene. And what it does, it's multiple mixture of multiple alkanes plus a ton of chlorine gas. What happens is you end up getting this hodgepodge of chlorinated hydrocarbons that insects cannot get a resistance to because it's different each time you make this stuff. It's not allowed to be used on food. Usually it's used on crops like cotton down in Bakersfield area, but it is really bad stuff. And you know, it's not good for wildlife. And another problem with this, the hulls of cotton sometimes are fed to ruminant animals like cows. And if that's the case, they're not allowed to consume by humans cow. So guess where it goes? To dog food and cat food. Bad stuff. Okay, so that's our unit on alkanes. Our next subunit is going to be on alkenes. Alkenes are double bonded carbons instead of single bonded carbons. And there are more reactions too. Are there any questions about the way I'm going to be asking questions on tests for reactions? So if you go to, don't forget to print this thing off. Um, um, if you go to Files, Unit 1, Worksheets, I've given you some practice worksheets. Besides the dry labs. Okay, so draw the following molecules.
Professor, do we know if the lab manual and the lab packet are in yet?
Yes, they're not in yet. I'll continue to
Thank you.
I'll continue to give you digital copies and handouts.
Thank you, Professor.
They never I don't know how to speed them up. You know, I gave them all the materials they needed a while ago, and they didn't even say whether they received them or not. It's like, so don't worry though, I'll always be giving you in. If you want the digital version, if you go to files under lab related, you'll see a dry lab 0-3. It's a PDF file. Some people, because they're using a tablet, want to have a digital version of it rather than having to digitize it themselves. Okay,
Thank you very much.
sure. Name the following structures. So this is typically an early worksheet. Now you should be able to we've covered all these in lecture. One thing we didn't cover are these little, instead of a plain line, it's a wedge. Instead of a plain line, it's these dotted dashes. What that means is the dotted dashes go into the page, the wedge comes out of the page. Instead of being a flat molecule, it's a three-dimensional molecule. Normally, we don't get into that much until later in the semester. This person, I got these worksheets from a colleague of mine up in Tacoma, and he and I used to teach this class, and we give each other worksheets. So this is where it came from. So this would be a good one to start on. I know some of you, was it Nicole that sent some corrections out? Nicole's online, right? Thought I saw her name. Anyway, you should be thinking about naming these guys. Now, that's this is subunit 2 for alkenes. These are all double bonded and aromatic. Oh, I see you, your mic doesn't work. Sorry. Okay, that's what I wanted to cover today. And I'm not, this stupid vaccine, I'm really dragging. I must have slept 14 hours last night. And I kept waking up because I'd roll over on my sore arm and wake up and stuff. So, all right. Any questions? So do your dry lab 2 at home, or you can work in a study group at school. Either way works well. We're not, let's see. The let's see, homologous is just a series of dry lab 2. It's just a series. Oh, excuse me, it's dry lab 1, because dry lab 0 is the first, yes, I'm sorry, dry lab 1. Yes. So you should have finished dry lab 0. Most people last week, I noticed, had pretty much finished it or done it at home. So a homologous series is just a string of carbons, all the same functional group, which would be all alkanes. It's just that, let me show you that graph. See, these alkanes are very, very structurally similar, except for one difference, is that it has an increasing number of carbons, single bonded carbons. And they call this a so this would be the series 1 through 10 of number of carbons up to decane. Homo means the same. Homologous series. Now, the boiling point is going to go up because the molecule is bigger, or the melting point. And these just have LDS in them. So that's all you need to know about the homologous series. It's just, and they can be an alcohol, they can be an alkene, they can be any molecule. If all you're doing is putting in more carbon hydrogens for the series. Now we're going to be using this graph here a lot on boiling point, number of carbons, because we're going to start putting in different classes of molecules on this graph. This is for alkanes. We're going to add to that the next lecture alkenes and aromatic compounds. And then we're going to add to it again for alcohols, subunit 3, and ethers. And then in the unit 2, we're going to be adding in aldehydes and ketones and fatty acids. And so anyway, we'll just keep adding to this, and you'll see where the different classes of molecules fall regarding, and this is totally IMF related, this graph. Okay. Should I answer your question? I forgot who asked the homologous.
Yes, Professor. Thank you.
Sure. Okay. What I'd like to do is for all of you to view this video on the pre-lab write-up for your first wet lab, which will be the alcohol lab. I'm just not feeling very well at all right now, but I did want to finish that alkane unit. Okay, and this is under modules. Oh, good question, Kyle. I think I'll change the assignment to a little later. Thanks for bringing that up. Okay, there any other questions about anything?
Professor, I had a quick question just about the safety.
Yeah. The safety contract?
Yeah, so I know that we just sign it and then submit it to the assignment, but at the bottom there's like a Chem 400 review. We don't have to do that, right?
And 400, yeah.
Yeah, like attached to the safety contract. If you just like scroll down, there's like 40 something questions and but it says like for Chem 400 review.
Yeah, all the chem classes use the same safety contract. And sometimes teachers will give a quiz and some don't. But you guys have already been through 305, so I'm not going to dwell on that. The safety contract is it's exactly like 305, except with the lab aprons. Other than that, it's pretty much the same.
Okay, so then pretty much just submit our signatures.
Signatures, yes, on both
Okay.
the
And then you just want us to print those out and then scan them and submit them?
yeah. You can also let's see, oh, I need to be in Canvas, not on my local drive. So if you have a tablet, you can pull it into your tablet, a digital copy, sign it, and then just save it out.
Okay. Also for the laboratory safety contract, is that the same as the district lab waiver? Because I can't find the district lab waiver in
It's right
files.
here.
So
It's at the bottom.
it's at the bottom of which tab? The
Files, lab related.
files lab related. All right.
Do you see it? This thing says REV5 in it, waiver.
Files lab related, and then you said REV.
Second from the bottom.
All right, I see it. Thank you.
And then the contract is up at the top.
Got it. All right.
And those are also called easy points. Let's see, while I'm here. Okay, change the due date. Now these three labs, 1, 2, 3, are all those multiple choice. And if I did not cover it in my lecture, skip that question. Because what I do to grade these, I choose 10 random problems that I covered in a lecture. And that's how I look at these. Most people do fine on the dry labs. Because you can take as long as you want to do them. They're not time constrained or anything. Okay, any other questions regarding assignments or anything like that? Okay, well, I'm going to go ahead and end this, and then I'll go and render the file and upload it. So it should be there, say 45 minutes from now. Okay, everyone. Have a good weekend. I won't see you till Monday. Take care.
Thank you, Professor. Have a good weekend. Feel better.
Thank you. You just interacted with my Google. Tammy.
Professor,
Yeah.
I have a quick question. For the worksheets that you give us on Canvas, are they similar to how the tests will be?
Yes and no. Go to on Canvas, go to Files, Test Related, and look at the practice tests.
Oh, okay. Okay, thank you.
And that'll give you the how long the tests are, how I ask questions. Those are really good. I should have at least. Um, I can give you lots of practice tests. I've been teaching this so long.
Yes, please. I would appreciate that.
I don't know how many are there now. Let me see. Yeah, I mean, there's a number of them.
Alrighty. I'll take a look at them.
Yeah, start with Chem 131 was the name of the class up in Tacoma, by the way.
Hmm.
I mean, here's two that would be good to start with.
Alrighty.
Three, you know. Could you send me an email to remind me to create keys for these three tests?
Oh, yes. Yeah, I can send you an email.
Oh, okay. Regarding that?
Yes.
Okay.
I think they are already there, Professor, because I was going over the practice test and some of them they have the key uploaded.
Okay. I don't know if these correspond. And these keys up towards the top. Well, if you can match up the keys with the test questions, that should work.
Okay.
You know, it's pretty. And we haven't talked about alkenes yet, the double bonds or benzene rings yet, or alcohols. Here's one on IMFs. And identify why is this a strong or weak, whatever. Here's a multi-step synthesis problem. And we'll be going over all this. I mean, some of these questions we haven't talked about at all in lecture.
Hmm.
You know, this is subunit 3 for ethers and alcohols. You know, anyway, this will give you an idea of how I ask questions. So, and I'm going to do multiple choice because I like to give partial credit. And multiple choice are either right or wrong, no partial credit at all. So by doing fill-ins, I can give you partial credit. But anyway, there are practice tests there.
Okay, thank you.
And that would be good to work in your study group too.
Hmm.
Okay, are there any other things you want to tell me I've done wrong? or at it? Oh, I'm surprised I got through that, finish up that alkane lecture. I'm gonna go back to bed here in a minute. I don't know why, I'm real sensitive to those vaccines. And ever since the first vaccine, I think I had COVID about right when the pandemic first started, because I had pneumonia And then they gave me that PCR test. And the early PCR tests were really, really uncomfortable. They stuck this wire gauze up your nose all the way to your throat on each side. And then it took like 2 weeks to get the results. It was like crazy and real expensive. It was like $800 or $900. It was like crazy. So, and about that time, I lost my sense of taste and smell. And I think I had COVID, even though I had a negative test result, because those early PCR tests were, they had a lot of false negatives. And so, anyway, still wore my mask. I believe in masks. So, okay, all right, everyone, I'm going to sign off here. And again, everyone have a good numbers of days till Monday.
Goodbye. Get better.
Thank you. Bye, you guys.
Bye, Professor. Thank you.